In the dark realms of the universe, revered physicist Brian Cox reveals an unsettling truth. A narrative that underpins our very existence, the Big Bang, is not as we once knew it.
So the Big Bang is an event when space gets very hot and very dense and filled with particles. And that may happen again. There's a theory called eternal inflation. And it's actually the most popular theory, I think, at the moment, for what happened, for why the Big Bang is the way that it is. Inflation is the idea that space-time was around before the Big Bang, and it was expanding extremely fast. And there was doubling in size in the most popular of these theories every 10 to the minus 37 seconds. So it's an unimaginably fast expansion. And then the idea is that draws to a close, so it quite naturally sort of dies away and the expansion slows down. And all the energy that was taken, that was causing that expansion, sort of gets dumped into space and heats it up and makes particles, and that's what we call the Big Bang.
Shrouded in darkness, beneath layers of cosmic mysteries, it harbors a secret so profound, so terrifying, that it could forever alter our understanding of reality.
And that's the oldest light in the universe, which is, by the way, one of the pieces of evidence when people say, I don't believe in the Big Bang. The answer is, well, you can see it.
Imagine, if you will, a truth that transcends our very comprehension of time and space. A truth that redefines the Big Bang and all that we thought we knew about the inception of the universe. Prepare for a journey into the unknown, and brace for the unimaginable. The epoch predating the Big Bang has, until recently, been a realm wrapped in tantalizing obscurity. It is a zone where familiar conceptions of before dissolve into an ungraspable void of past eternity. Yet, the narrative of our universe doesn't commence with the Big Bang. It dives further into a period of colossal inflation, a cosmic specter that renders imagination feeble. Inflation. The term itself provokes a sense of profound intrigue. It embodies an idea so colossal and disconcertingly baffling, it requires a journey through a wild expanse of cosmic chronology. Brian Cox, a distinguished physicist, delivers an awe-inspiring account of the universe's rapid expansion in terms that render the mind spinning. If you started with the universe that was smaller than a single atom, then it would be bigger by a long way than the whole observable universe, in less than a millionths of a second. The revelation is nothing short of spine-chilling. Such an extraordinary period of expansion was not an idle spectacle in the cosmic timeline. Each phase of inflation was a cataclysmic event, triggering an eruption of energy so vast it defies understanding. This colossal energy is the primal womb that gave birth to the universe's plethora of particles. The lifeblood of every speck of dust, every star, every sprawling galaxy that we see today can be traced back to this epoch of cosmic inflation. The echoes of these monumental cosmic events continue to ripple through the universe. They shape the evolution of galaxies, stars, and potentially even the trajectory of humanity itself. The chilling reality of these cataclysmic events of the past can provoke a sense of dread, an unsettling awareness of our tenuous position within the vast cosmic scheme. Despite these hair-raising insights, a multitude of questions still lurks in the cosmic murk. What ignited the spark that propelled the initial phase of inflation? Why did this era of exponential growth abruptly halt? What nightmares lurked beyond this era, and what prophecies do they foretell for the future? As things stand, the answers to these questions remain elusive, lurking within the inscrutable depths of the cosmic abyss. Their disclosure promises to be just as petrifying as the questions themselves. Journeying into the pre-Big Bang era to grapple with the concept of inflation demands one to tread into a cosmic horror story. This expedition promises to unweave a narrative of our universe that is significantly more complex, more terrifying, and ultimately more wondrous than what one could possibly conceive. As Brian Cox aptly summarizes, that's where our current modern cosmology is. Prepare for a voyage that whisks you through a gauntlet of startling revelations and daunting truths about the cosmic order. This journey through space-time aims to illuminate the horrifying beauty of the cosmos, revealing the minuscule role humanity plays within this grand cosmic theater. Unraveling the mysteries of the cosmos is essentially a pilgrimage through the annals of cosmic horror. But it's a journey that's absolutely crucial, as only by comprehending the terrifying epics of our past can we hope to navigate the uncertainties of the future. With each revelation, the cosmic puzzle seems to grow more complex, the labyrinth of cosmic truths ever more convoluted. The universe, in its silent majesty, holds secrets that promise to shake the very foundations of our understanding. But one fact remains chillingly clear. As Cox declares, the universe undoubtedly extends beyond the little bubble that we can see. In this seemingly infinite expanse, human existence is but a mere speck, adrift on the cosmic currents, a testament to the universe's terrifyingly beautiful complexity. The multiverse theory, an idea once considered an absurd figment of wild scientific imagination, has begun to make an unsettling yet fascinating appearance in cosmology, thanks largely to its proponents like Brian Cox. It is an idea that tugs at the very core of human understanding of reality, an idea that not just shatters the uniqueness of our universe, but also presents a possibility so bewildering that it could even redefine the concept of existence itself. Think of our universe, a vast expanse of space-time, galaxies, stars, and planets, stretching out over billions of light-years, filled with structures and phenomena governed by a set of rules, our laws of nature. Now, imagine an infinite number of such universes, each existing independently, each potentially bound by its unique set of rules and physical constants. That's the essence of the multiverse theory, an essence that is as fascinating as it is terrifying. If our universe is just one of an infinite number, there could be universes out there with variations in the laws of nature that we can't even begin to comprehend. The fundamental constants of nature, the speed of light, the strength of gravity, the Planck constant, the charge of an electron, the scaffolding upon which our understanding of physics rests, could be entirely different in these universes. This presents an eerie picture. There could be universes where gravity repels instead of attracts, or where time might run backward. There could be universes where stars and galaxies never form, universes devoid of complex structures of life. There could be universes trapped in their own physics, universes forever doomed in black holes or cosmic voids. There could be universes dying moments after their birth, their existence fleeting in cosmic time. On the flip side, there could be universes with physics that allow for phenomena considered impossible in ours, faster-than-light travel, time manipulation, realities that would sound more like science fiction than science. But therein lies the terror of the unknown, for such realities could pose existential threats that we could never prepare for. Brian Cox, known for his penchant for dealing with existential questions, has often discussed the terrifying implications of a multiverse. The very idea of constants not being constant but varying from one universe to another creates a feeling of cosmic horror. It is a stark reminder of our fragility and the tenuousness of our existence. If the constants of our universe were ever so slightly different, life as we know it wouldn't exist. The universe would be an entirely different and possibly hostile place. The Goldilocks condition of our universe, which allows for the existence of life, might just be a lucky draw in the grand cosmic lottery of the multiverse. However, even this luck comes with its existential dread. If there are universes with every possible combination of constants, then the existence of universes where life is impossible or where life is inevitably doomed is not just a possibility, it is a certainty. This alarming concept, a scientific perspective that stands on the precipice of the unknown, is a testament to the ceaseless quest for understanding the nature of reality. It's a terrifying ride on the roller coaster of existential dread, punctuated with moments of awe at the sheer scale and diversity of the multiverse. This is not just science, it's a cosmic horror story unfolding, with humanity holding a front-row ticket to witness its chilling revelations. In the realm of space-time, a ceaselessly active ballet of cosmic proportions is taking place, choreographed by the celestial bodies. Each star, each planet, and each galaxy, from the puniest to the most colossal, contributes to the ballet, forming the curvature of space-time. This stage, upon which the universe conducts its performance, bends and folds under the influence of gravity, the force that governs the cosmic dance. And here is where our protagonist, Brian Cox, a renowned physicist, steps in to offer his insights on the subject. As one of the most preeminent voices in the field, Cox's interpretations provide a horrifying yet fascinating window into the understanding of gravitational waves, the ripples in the fabric of space-time. To comprehend the role of gravitational waves in this grand cosmic ballet, we first need to grasp the concept of space-time curvature. As Einstein proposed in his theory of general relativity, gravity is not just a force, it's the warping of space-time caused by mass and energy. This curvature, shaped by the distribution of matter and energy, dictates the trajectory of objects moving within it. Picture a heavy ball placed on a stretched sheet, causing a dip. Now imagine a smaller ball rolling around this dip. That's gravity. But it's not just passive, it's active. When objects accelerate, they generate waves that ripple across the cosmos, gravitational waves. Gravitational waves are like invisible threads connecting the universe, spreading at light speed.
So that means that if you've got masses that move and things that happen, violent things that happen, you can get ripples in space and time that move out, just like ripples on a pond if you throw a stone into the pond. So these ripples in space and time from violent events will be passing through this room now because there have been very violent events out there in the universe. But they're very, very tiny shifts. But you can measure it using a process called interference. So you can measure very tiny changes in the distances.
These waves can spring from any accelerating mass, but the most potent sources are cataclysmic events, such as supernovae, or collisions of black holes or neutron stars. It's akin to a stone dropped in a pond, with the ripples becoming our gravitational waves. The difference? These waves are not just on a surface, they pervade through the entire fabric of space and time. Cox elucidates the terrifyingly intriguing part of this phenomenon, their implications on the cosmos. When two neutron stars collide, the resulting gravitational waves are so potent that they literally shake the universe, albeit minutely. Yet, the energy carried away by these waves is enormous. When black holes collide, the situation becomes even more dire. The resulting waves can create distortions that could, theoretically, tear apart anything in their path.
And there's a plot where you see the closing velocity of the black holes, and it's measured in tenths of a second. And you see that, so in 1/10 of a second, the closing velocity goes from 1/3 the speed of light to 2/3 the speed of light. So you imagine accelerating something 30 times the mass of the sun towards the other thing, with a change in velocity that's 1/3 the speed of light in 1/10 of a second. And then they merge together. And you get, obviously, a bang and space-time shakes.
As Cox warns, we live in a universe that is far more active and potentially hazardous than our tranquil night sky would suggest. Each second, countless gravitational waves pass through Earth, unnoticed by us, but not by the sensitive detectors built by physicists. One could almost picture it as a silent symphony of cosmic proportions, playing continuously, yet heard by none. The potential catastrophes that these waves could cause are still a matter of research. What if a potent enough wave passes through our planet? What effects might it have on our Earth? These unsettling questions remind us of our humble place within the universe and the vast unseen forces constantly at play around us. In conclusion, gravitational waves are another testimony to the terror and beauty of the universe. With Cox's explanations, we begin to grasp the magnitude of the forces at play, reminding us of our precarious existence in this cosmic dance. It's the silent whispers of these waves that tell the tales of cataclysmic events occurring billions of light years away, painting a picture of a universe far more dynamic, far more terrifying, yet infinitely more intriguing than we could ever imagine. The preceding moments of the Big Bang, the unfathomable genesis of everything we comprehend as the universe, are shrouded in a miasma of mystery and speculation. The terrors of the unknown unravel as theories about what existed before this cosmic event, once a field limited to philosophical discourse, has now become a cornerstone of cosmological examination, championed by prominent physicists like Brian Cox. One of the prevailing theories suggests that the Big Bang was not the beginning, but merely a stage in an infinite cycle of expansion and contraction, known as the Big Bounce theory. Imagine a universe that expands and contracts endlessly, each cycle marked by a Big Bang followed by a Big Crunch. The thought of our universe being one among an infinite sequence of universes, each doomed to die in its own Big Crunch, is daunting. These cycles of birth and death could result in variations across different universes. Variations so drastic that the laws of physics we hold as universal truths might be unrecognizable in a different cycle. This presents an intimidating view of reality that has the potential to disquiet even the most unflappable minds. Another prevailing theory proposes a pre-Big Bang epoch known as the Planck Epic. Named after Max Planck, it's thought to have been an era dominated by quantum fluctuations of space-time, a realm where gravity and other forces were unified and our understanding of physics falls apart. Brian Cox paints a chilling picture of this era as an alien landscape of extreme densities and temperatures, a place where the physics as we know it ceases to make sense. To deepen the dread, the highly speculative yet fascinating hypothesis of a parallel universe existing before the Big Bang has been put forth. This theory suggests that our universe was born from the collision of two three-dimensional worlds moving along a higher dimensional space. The very idea of such an existence is disconcerting, to say the least. Supporting these mind-bending theories are not just mathematical models and speculations, but actual experimental observations as well. Cosmic background radiation, the afterglow of the Big Bang, presents minute temperature fluctuations that lend credibility to the theory of inflation and hints towards a universe before ours. Quantum gravity, though still a developing field, is making strides in unifying quantum mechanics and general relativity, providing potential insights into the Planck Epic. Moreover, the detection of gravitational waves, ripples in the fabric of space-time, has opened up new avenues for understanding the early universe. These waves might bear the imprints of events before the Big Bang, turning the terror of these theories into a tangible reality. These theories and their experimental backing, eloquently explained by Brian Cox, don't just serve as a testament to our pursuit of knowledge, but also push the boundaries of our imagination into territories that are as petrifying as they are mesmerizing. The understanding of our cosmic past brings with it the fear of an inscrutable reality, but also the wonderment of a universe far more complex and stranger than our wildest dreams. It's a hauntingly beautiful cosmic horror story, a story that continues to unfold, forever spiraling into the abyss of the unknown. The cosmos, in all its vastness and enigma, sets the stage for an awe-inspiring spectacle. At the center of this grand drama, we find the observable universe, the segment of the cosmos within our observational capabilities. According to Brian Cox, it's an arena that teems with about 2 trillion galaxies, each housing millions to trillions of stars. Yet the chilling truth is that this colossal entity represents merely a fraction of the actual universe. The concept of the observable universe creates an unsettling feeling of insignificance. It introduces us to a broader reality, where our entire cosmic neighborhood shrinks to a mere dot on the endless cosmic canvas. The dread increases when we try to comprehend what lies beyond the observable universe. It's a realm hidden from our sight, where the universe continues in ways we may never understand. Beyond this limit, according to some theories, lies an infinite expanse where our universe is merely one in a potentially endless series of bubble universes, each with possibly different laws of physics and dimensions. A place where even the fundamental constants we take for granted may no longer hold, leading to realities inconceivable to the human mind. The sheer thought of these innumerable realities can invoke a harrowing sense of dread and unease, underlining the vulnerability of our existence. However, if the vastness of the universe wasn't terrifying enough, Cox delves into a more ominous matter, the potential end of the universe. While it's still a matter of scientific debate, Cox brings forth several scenarios, each adding a new dimension of existential fear. One such scenario is the Big Freeze, where the universe continues to expand until all stars exhaust their fuel. The galaxies will dim, black holes will evaporate, and the universe will approach absolute zero temperature, a dark and cold cosmic graveyard. The Big Crunch is another possibility, a mirror image of the Big Bang, where the universe stops expanding and begins contracting, culminating in a singularity, a point of infinite density. This scenario paints a picture of a universe that ends in fire and chaos, a stark contrast to the cold death of the Big Freeze. A more speculative scenario is the Big Rip, where dark energy, the mysterious force driving the universe's accelerated expansion, becomes dominant. In this grim finale, galaxies, stars, and even atoms will be torn apart as the fabric of space-time itself succumbs to the relentless pull of dark energy. Each of these apocalyptic outcomes brings a dose of existential dread. The inevitable end of the universe, as expounded by Cox, serves as a chilling reminder of the ephemeral nature of existence. The observable universe, with its mind-boggling vastness and the looming doom, turns out to be a cosmic horror show, a spectacle that fascinates and terrifies in equal measure. In this theater of cosmic events, we humans, as observers, are left grappling with the terror of the unknown and the unsettling reality of our existence. In the cosmic theater of the universe, the tale told is one of awe, mystery, and existential terror. From the pre-Big Bang era and the lightning-fast inflation that followed, to the concept of a multiverse with varying constants of nature, the revelations made by Brian Cox paint a picture both beautiful and terrifying. Cox's insights into the potential existence of realms before the Big Bang, supported by experimental findings, has opened a Pandora's box of eerie realities and haunting uncertainties. The vastness of the observable universe, a stage for countless celestial dramas, instills a chilling sense of insignificance and vulnerability. Gravitational waves, these invisible ripples dancing at light speed across the cosmic ballet, bring with them the threat of cataclysmic cosmic events, from the collision of black holes to the merger of neutron stars. The curvature of space-time, an embodiment of gravity's cosmic dance, echoes the ceaseless activity and potential danger of our universe. The uncertainty surrounding the universe's ultimate fate, from heat death to the Big Crunch, hangs over humanity like a cosmic sword of Damocles. The startling revelations from Brian Cox add not only to our understanding of the universe, but also to our realization of the potential threats lurking in the cosmic shadows. Yet, even amid this existential dread, humanity's curiosity and quest for understanding remain undeterred. But the curtain hasn't fallen yet. As our understanding of the universe expands, so does the horizon of the unknown. What other terrifying secrets does the cosmos hold? What uncharted territories await our exploration? As we delve deeper into the cosmos, we teeter on the edge of the abyss, eagerly waiting to uncover more about the cosmic ballet, where we are but mere spectators.